Hi, in this video we will explore the reverse proxy feature of the API gateway and demonstrate how to configure it to forward incoming requests to backend microservices. These microservices can run on either TCP or Nonstop IPC protocols. Let us dive in with a practical example. Let us look at the available samples. We will select the Manage Nonstop Microservices sample. This sample includes two key files, the README and the application.properties file. The README provides detailed configuration steps and information about the sample. Our backend environment includes three microservices: users, products, and orders. We will see how requests are routed to each microservice and how responses from multiple services can be aggregated. Let us start with the configuration. Open the application.properties file and configure essential parameters, including the pathmon name and the port where the microservices will run. These values can be set based on project needs. Next, we return to the sample page and provide a project ID. For this demonstration, we will use the default ID. Click Start. This triggers an automated process that creates the project and starts the sample backend service. Once the project is created, navigate to the Projects tab and open the Microservices project. Under the Files tab, all project files are available. Open the integration.caml.yaml file, which contains pre-configured values. Here, we see a REST API named Order Summary REST API. This API is mapped to a route that generates the order summary. Switching to the Routes tab gives us a clearer view. There are 4 routes in total. The first 3 routes forward requests to individual microservices, and the fourth route aggregates responses from 2 microservices. To forward requests to a specific microservice, we use the Nonstop Proxy Camlet, a specialized component designed for reverse proxy use cases. Selecting the Nonstop Proxy Camlet reveals configuration details on the right. Key properties include transport protocol, specifies whether the microservice listens on Nonstop IPC or TCP. Context path defines the path on which API gateway requests are forwarded to the specified microservice. This is crucial. HTTP method allows restriction to specific HTTP verbs. Security configuration supports basic auth, bearer token, and OAuth 2 for secure API access. Pathmon and server class settings required only for Nonstop IPC based microservices. For TCP based microservices, this can be skipped. HTTP URI, the actual endpoint where the microservice is hosted. Using this configuration, any request to API users is forwarded to the user's microservice. The second and third routes forward requests to API products and API orders respectively. Now, Let us look at response aggregation. The fourth route demonstrates how to aggregate responses from multiple microservices using the multicast component. In this demo, we are aggregating 2 services, but you can scale this to as many as you need. It sends HTTP requests to the products and orders microservices and then aggregates the responses using a custom aggregation strategy. It is currently configured to send sequential HTTP requests but can be configured to send parallel HTTP requests as well. In this implementation of custom aggregation strategy, message bodies from each microservice are collected and combined into a unified response which is returned to the client. This approach is ideal when consolidated data from multiple services is required. Let us test the setup by invoking the configured REST APIs. To summarize what we have covered, API gateway is configured as a reverse proxy to forward requests to backend microservices. Both TCP and Nonstop IPC protocols are supported. How to add security at the API gateway level. And finally, aggregating responses from multiple microservices into a single unified response. That's it for this demonstration. Thanks for watching.